Welcome to my series of video on Proteus as electronic simulation and prototyping tool. In this video, I'm going to show you how you can simulate LCD using Proteus and microcontroller. You first of all start by designing a schematic diagram. Then you click on New File. Then here you write the name of schematic design using LCD simulation. Then choose folder. Then select folder and then next, and finish. Now we need two components. We need LCD. I'm going to use this one, 12 columns and 2 rows. Then I'm going to use Arduino board for microcontroller. This one I know is the best one. Now I have two components. Now this is Arduino. It's going to be rotated up to 270 like this. Then LCD. Then press it here. Good. Have Arduino and LCD. I'm going to connect them. Please, you can open the link in the description to see the pinout for LCD and description of each pin. Okay, everything's there. You can go through document and see everything about each pin and how each pin is connected to Arduino. You can see this is LCD. Now we have pin description here. VSS, VDD, VEE, RS, read and write enable, and data pin from 0 to 7. Then down we have pinout. Pinout is showing how LCD is connected to Arduino. Down here we have a table showing LCD pin and the connectors. VCC is connected to ground, VDD 5 volt, VEE 5 volt, RS up to data pin. Then we have Arduino code starting with encoding library, declaration of pins, creation of LCD object. Then this is for starting LCD. Then you have a sample code written inside the void setup. Now let us place terminals. We have power here and the ground here. Then this ground is going to be rotated up to 180. Good. Then this is 5 volt and this ground is going to be connected to the ground. Then ground is connected to ground. Then this is 5 volt Then this is VDD. The VDD is connected to 5 volt. Yes. Then R1 is going to be connected to data pin. Data pin, for example, number 8. Then read and write. Connected to ground. Ground is this one. It's going to connect read and write. Then this enable pin is going to be connected to data pin 6, for example. N5 is going to connect D4. Where is D4? This one is going to connect D5. Data pin 3 is going to connect D6. Then data pin 2 on Arduino is going to connect data pin 7 on LCD. Now the connection is done. LCD is properly connected to Arduino. Let us develop a firmware for simulating LCD to check whether it is connected well and it is working properly. Keep watching. For developing firmware, you have to open Arduino IDE for writing codes to be uploaded. Then above setup, we want to say I want to declare. We need 6 pin for using the LCD. We need a pin for register select. Of course, it is an int. RS pin, which is in the schematic design. RS is connected to 7. Okay. Then int enable. It is enable pin also is needed for using the LCD. Then enable is connected to pin number 6. Then int D4 is connected to pin number 5. Yes, it is connected on pin number 5. Then we need D5. You can call it any name, it is a variable. It is connected on pin number 4. Then we have D6, which is connected to pin number 3 on Arduino. Then D7 is connected to pin number 2 on Arduino. Those are pins necessary for using LCD. 6 pin. The pin connecting register select, the pin connecting enable, pin connecting D4, pin connecting D5, pin connecting D6, and the pin connecting D7. Okay. Now those pins are going to be passed to liquid crystal. Then we are going to import here library. First of all, check whether library called liquid crystal is installed here. And see it is here already installed. Means here I want to include the library called liquid crystal.h. Yes, liquid crystal. Good. Now I want to call an object from that library. It is called the liquid crystal. It is going to take a variable called LCD that you can call it any name. Then this LCD is going to take 6 parameters starting from RS pin, then enable pin, then D4, then D5, D6, and D7. Good. Now set all variables. Library is included. I now an object liquid crystal used to create LCD with 6 pins. Good. Then after defining an LCD, we want to start it. It is LCD, the same name as written here. Dot begin. Now set the column and rows starting from column. The column number of column for our LCD is 16. Then the row is 2. Means our LCD has 16 column and 2 rows. The first parameter is column, number of column. Then you can clear the LCD using function called clear. Now we are ready to use our LCD. You can say LCD. We want to set the cursor where it will start writing. Dot is LCD dot set cursor. Then it is going to start writing starting from 0, column number 0 means it is the column number 1 and the row number 1. I'm going to say LCD dot print my video. This is my video. Yes. Make sure you are not exceeding 16 characters. Then I have 1, 2, 3, 4, 5, 6, 7, 8. 16 characters. Then going to say LCD dot set cursor means we are going to move the cursor to the second row. It is column number 1, row number 2 means 0, 1. 1 represents second row. Then here, one the LCD dot print, then message to be displayed like this. Then save. Then you want to click for LCD somewhere. Then click on save, install and document Arduino. Then after saving, we are ready to go with the creation of the .x file. Click on stretch dash export finally. When it is compiling, once it finish, we'll be able to import our file. Now it is done. From here, you double click on microcontroller. On program file, you click on this icon. Then navigate for your X file stored on document Arduino LCD firmware with Arduino, then LCD firmware .exe file, then open, then start simulation. You see, it's working. This is my video. Then on the first row, then on the second row, have another message. For example, I want to display another message to the second column. Let's remove this one video by someone else, LCD.set cursor. Then the cursor is going to be set on which column? The row is number 1. On which column? We have to count where the first message displayed stopped. It is stopped on column number 1, 2, 3, 4, column number 8. Which means we are going to start by, we are going to skip one column, we are going to start from 10. Then say lcd.print by the name. Then semicolon, save, export, compile the binary again. Then unexpected token, there we have semicolon, save, and export the binary. Wait. Done compiling. Then stop simulation and start it again. You see, two messages on one column, of course, first column, and one message to the second row. We have two messages displayed on one row, and on the second row, we have one message. That is the first message displayed from column number 1 to column number 8. Then skip one column from column number 10 on row number 1, display another message. Then on second row, but first column, starting from first column, display another message.